Until World War II, flying boats were considered the only viable option for building large aircraft. However, the future of post-war aviation lay in faster, more efficient land-based planes. Yet some designers resisted this shift. Just as the aviation industry abandoned the large flying boat, three of the biggest ever constructed made their debut. Two would soon be forgotten. A staunch advocate of flying boats, it remains both a living relic and a local legend. When humanity first attempted to cross oceans by air instead of water, aircraft designers followed a straightforward logic: build ships that could fly. With 3/4 of the Earth's surface serving as a natural runway, the massive flying boat was not just a logical choice, it was a practical one. And for the first 4 decades of powered flight, flying boats dominated aviation. Today, however, they are nearly extinct. This is Vancouver Island, British Columbia, off Canada's Pacific coast. Near the center of one of its largest lakes, 2 relics from the past remained alive and well. These are the largest operational flying boats in existence. With a wingspan of 200 feet, they stretch wider than a 747 jumbo jet. Originally built over 70 years ago for the United States Navy, the Martin Mars was designed as a long-range Its massive hull carries not bombs, but water, 30 tons of it, to fight a different enemy: forest fires. Declared obsolete by the Navy in 1956, the Mars avoided the scrapyard thanks to a group of Canadian logging companies. Now, after more than 60 years of successful firefighting, the Mars water bomber stands as a living relic from an era when strength was the guiding principle in flying boat design. The first JRM Mars made its debut in July 1945. And its christening, the theme was grandeur. Master of Ceremonies Glenn L. Martin proudly prepared to launch the Navy's largest flying boat ever, one that would soon become among its most successful. The ceremony resembled the launching of an ocean liner or battleship, rather than an aircraft. But in many ways, the Mars was exactly that, a ship with wings. Martin envisioned it as the next step toward massive flying boat transports of the future. Aviation pioneer and staunch advocate of flying boats, he had introduced the famous China Clipper here a decade earlier. Now he took pride in unveiling the first of 20 JRMs, ordered by the Navy, whose confidence stemmed from the wartime success of the prototype, seen here joining the ceremony. The prototype Mars, designated XPB2M, had been commissioned by the Navy as early as 1938. It took 3 years to complete before its long-awaited launch at Middle River, Maryland. Once delivered, it would become the largest patrol bomber of World War II, boasting an unmatched range of over 4,900 miles. Its massive 200-foot wing housed 4 Wright Cyclone engines, each producing 2,200 horsepower. For the next month, extensive engine and system tests were conducted to prepare the XPB2M for flight trials. But before it could take off, the Mars program faced an unexpected setback. On December 5th, 1941, during engine tests, the number 3 propeller failed to shift into reverse. The engine quickly caught fire, sending a propeller blade hurtling into the fuselage, narrowly missing the flight engineer. With no other options, the crew removed the anchor and ran the aircraft aground in an attempt to save it. Before the flames could be extinguished, the No. 3 engine burned completely through its mounts and crashed to the ground. Though the fire was eventually brought under control, the wing and engine nacelles sustained significant damage, and the rogue propeller had torn a massive gash in the fuselage. Despite the setback, the crew managed to save the aircraft. Walking the length of the wing, engineers worked methodically to free the massive flying boat from the riverbank. In under 30 days, repairs were complete, and the Mars was ready to resume final testing. With a new No. 3 engine installed, the XPB2M was ready for its first flight test on June 23, 1942. Once testing was complete, the decision was made to convert the XPB2M from a bomber into a transport aircraft. The bow and gun turret were removed, the decking was reinforced, patches were added, and cargo loading equipment was installed. For the next 18 months, the aircraft remained at Martin for final modifications and testing. The Navy finally took delivery of its massive transport at Patuxent River, Maryland, on November 27, 1943. Temporarily assigned to the Naval Air Transport Service, the aircraft, affectionately called the Old Lady, soon made history with a record-breaking flight from Pax River to Natal, Brazil, covering 4,375 miles while carrying a 13,000-pound payload. It was only the first of many record-setting flights for the Mars. By January 1944, the demand for priority cargo was greater than ever to sustain the Allied island-hopping campaign in the Pacific. As Japan was forced onto the defensive, the Old Lady became a crucial asset, flying extensively between Alameda, California, and Hawaii, the world's longest over-water air route. From there, other naval air transport aircraft took over, delivering supplies to forward areas for the final push against Japan. Thanks to its immense cargo capacity, the Old Lady became an invaluable asset in the Pacific War. During the brutal battle for Iwo Jima, she transported tons of life-saving plasma across the Pacific. By the time she was retired in March 1945, she had carried more than 3 million pounds of personnel and supplies, completing 78 round trips between San Francisco Bay and Honolulu. The Navy, highly impressed with its performance, placed an order for 20 improved versions in January 1945. Glenn L. Martin couldn't have been more pleased.
The Mars flying boat, wingspread 200 feet, height almost 45 feet, largest yet in operation. At Baltimore, the first of a fleet of 20, the Hawaii Mars is ready for flight. 19 others, named after Pacific islands, will join her in the Naval Air Transport Service. Down to the water for a takeoff. The Mars is more than 120 feet long and weighs 72.5 tons.
He got the publicity he sought while ensuring the Navy received exactly what it needed. Unlike the prototype, the newly designated JRM-1 Hawaii Mars was designed from the outset as a dedicated cargo transport. The design incorporated greater cargo space, larger hatches, and a massive cargo hoist mounted beneath the wing. However, The most noticeable change was the switch from the old lady's twin-tail fins to a single vertical stabilizer and rudder. With more powerful engines and increased fuel storage, the new model promised greater range and lifting capacity. But with the war ending in September 1945, post-war budget cuts reduced the original order of 20 JRMs to just 5. For the next 11 years, the mighty Mars continued flying the Pacific routes, repeatedly breaking its own weight-carrying records and serving the Navy with distinction. Glenn L. Martin had found a satisfied customer in the U.S. Navy, but he had bigger ambitions. He envisioned the Mars as the first step toward a fleet of giant commercial flying boats. To promote this vision, the Martin Company produced a film showcasing the Mars as a luxurious passenger airliner. Evoking the golden era of the Pan Am Clippers, the sketches depicted plush accommodations, spacious seating areas, a saloon, washrooms, and a lounge. For Martin, the age of the commercial flying boat was only just beginning. But in the post-war era, it was the beginning of the end. Airlines were now shifting toward large, 4-engine land planes. Even Pan American Airways, once the staunchest advocate of the Clipper flying boats, had abandoned water-based aircraft. The future belonged to fixed runways and expansive airports. The massive airfields constructed during the war now made air travel more accessible, and cities without suitable water facilities could finally be connected to international routes. Passengers still enjoyed the luxuries first introduced by the great Clippers. But the era of landing on water was rapidly fading. Meanwhile, across the Atlantic, one British aircraft company resisted the march of progress. In 1946, Saunders-Roe responded to an order to build the largest commercial flying boat ever intended for airline use, the SR-45 Princess. The British Air Ministry envisioned it serving transatlantic routes for British Overseas Airways Corporation, or BOAC, its nationalized flagship carrier. But BOAC did not share the government's enthusiasm for the 10-engine behemoth. Despite BOAC's lack of commitment, Saunders-Roe proceeded with the construction of 3 prototypes at their Cowes plant on the Isle of Wight. The next 6 years of development, construction, and testing were marred by delays, miscalculations, and to a considerable extent, unrealistic expectations. With the arrival of the jet age and the rapid advancements in high-speed aircraft design, the Princess began to seem like a step backward. However, despite its traditional appearance, the Princess would incorporate some innovative concepts. Its 2-deck hull, known as the double-bubble section, would feature cabin pressurization and air conditioning systems, groundbreaking advancements for its time. Another innovative feature was the use of gas turbine engines. While still in their infancy, these engines offered a high power-to-weight ratio than traditional piston engines, which encouraged Saunders-Roe to continue their ambitious project. The Bristol's Proteus II propeller turbine was eventually chosen for the Princess. 4 contra-rotating pairs and 2 single outboard engines, for a total of 10 units, were installed. Unfortunately, this underdeveloped engine became a major source of delays and problems during the final testing phase. By August 1952, the first prototype was finally completed, 3 years later than the original projected flight date. The Princess was enormous. Its hull measured 140 feet in length, 55 feet in height, and its wingspan reached 219.5 feet, nearly 20 feet wider and 10 feet taller than the Mars. The launch was initially scheduled for August 19th at Cowes, but a strong northeast wind forced a postponement. 2 days later, just after midnight, the Princess was finally lowered into the water. Its dependence on favorable sea conditions highlighted one of the key drawbacks of flying boats. On August 22nd, the Princess was ready for flight. The 11-member flight crew boarded and conducted taxiing tests before attempting takeoff. Despite the many delays, the Princess was deemed a technical success. At the time, it was the heaviest all-metal passenger transport ever built, and the largest aircraft powered by gas turbines. The greatest technical achievement of the Princess lay in its power control system. While muscle power had been deemed impractical, the rudder, elevators, and ailerons were all power-assisted with hydraulic boosts. The captain reported excellent handling characteristics, both in the air and on water, but the Bristol Proteus II engines were severely underpowered. Advertised as delivering 350 horsepower, they only produced about 250. The Proteus III engines intended for the final model weren't ready in 1952, and their delayed installation would have caused further setbacks. However, by this point, the Princess and the flying boat as a concept were already on borrowed time. On September 2nd, the Princess made its public debut at the Farnborough Air Show. There was no question that the massive flying boat left a lasting impression on the crowd. However, that impression was nearly shattered in a near-disastrous incident. The pilot had pushed the Princess to such a high speed that he struggled to roll the aircraft back to level flight. An accident was narrowly avoided. Despite its successful flights, the Princess's future remained uncertain. Plans to provide a 105-seat capacity with luxurious accommodations were never realized, and BOAC continued to hesitate on its commitment to the massive aircraft. As early as February 1951, it was unofficially announced that the third prototype would be scrapped to save costs. In March, there was even a suggestion that the Princess could be repurposed by the Royal Air Force for troop transport, further highlighting BOAC's lack of interest. The idea, too, received only tepid support. The Princess made its final public appearance in September 1953, repainted in a new blue, yellow, and white livery. The entire Princess program was discontinued by June the following year. With no further orders for the giant flying boat, the Air Ministry decided to preserve all three prototypes. Coats of preservative polyvinyl plastic were applied to protect them from deterioration. As a flying boat, the Princess had performed exceptionally well, both in the air and on the water. As a viable alternative to the faster and more efficient land-based aircraft of its time, the Princess was doomed from the outset. It would never lead a new generation of flying boats, but instead suffer the indignity of preservation in a dormant state. Until 1965, all three Princess models remained inactive. That year, workmen began dismantling the second and third prototypes for potential use by NASA as a transport vehicle for the Saturn V rocket. The same booster that would carry the Apollo astronauts to the moon. However, true to the Princess's misfortune, this order ultimately came to nothing. With the second and third models scrapped, the only Princess ever to fly was eventually towed to a wrecker's yard in Southampton in April 1967. This marked the end of the last flying boat ever built for airline use, a victim of its era. As the Princess was reluctantly moved to its final resting place, the procession served as a symbolic requiem for the flying boat.
The huge fuselage for the world's largest aircraft leaves its hangar in California to begin the 24-mile overland journey to the shores of the Pacific Ocean. One wing alone measures 165 feet, and the huge seaplane, when completed, will be powered by 8 3,000-horsepower engines. En route to a special graving dock, linesmen cut wires and shift poles to provide clearance for the huge plane. The mammoth hull will rest in this graving dock while the plane is assembled. As yet unnamed, the craft was designed as a cargo carrier, but it could be easily adapted to transport 700 passengers. This, the latest and largest transport plane, opens new horizons in man's conquest of the skies.
The H-4 Hercules, better known as the Spruce Goose, was another giant among giants, holding the record as the largest aircraft ever built. Its brief but fascinating story is matched only by its eccentric designer, Howard Hughes, oil millionaire, movie producer, and aviation record breaker in the 1930s and 1940s. It was Hughes's relentless determination and aeronautical expertise that carried the Hercules project through to completion, despite the numerous challenges encountered along the way. Originally, 3 of these colossal flying boats were ordered by the U.S. government in 1942 to combat the German U-boat threat against Allied shipping during World War II. The idea was that these flying boats would airlift massive quantities of men and supplies across the Atlantic non-stop, thus avoiding contact with enemy submarines. In a notable departure from conventional materials, the entire aircraft was to be constructed with materials deemed non-essential to the war effort. The hull, wings, and tail assembly, everything except for the engines, engine mounts, and hardware, were made of laminated wood, primarily birch rather than the more commonly used spruce. By 1944, however, the first aircraft had not yet been completed, despite the significant portion of the original $18 million budget being spent. Frustrated, the War Production Board decided to terminate the project. Many within the government viewed Hughes as a reckless playboy and doubted his integrity in relation to the project. Fortunately, President Roosevelt suggested that at least one of the aircraft should be completed, and a new agreement was reached. Hughes pressed on with the project, despite being on the brink of a nervous breakdown. By November 1947, after enduring 4 years of engineering challenges, material shortages, and a lack of skilled labor, Hughes was finally ready to conduct the first taxi test of the massive flying boat. Hughes had faced relentless criticism. In July, Senate subcommittee hearings were held to investigate whether he had improperly influenced government officials to secure war contracts. Hughes vigorously defended the project before Congress, denouncing those who claimed he had built an airplane that would never fly. On November 2nd, Hughes invited the national press and members of the Senate Investigative Committee to witness the scheduled demonstration of the Hercules' water handling capabilities. It was a breathtaking sight. The wingspan stretched 320 feet, longer than a football field, and twice the distance the Wright brothers had flown their first plane. The tail stood nearly 10 stories high. The crowd was undoubtedly impressed, but soon the unexpected occurred. As the H-4 Hercules reached 90 miles per hour, it lifted off the ground.
We are airborne, ladies and gentlemen. Really up in the air. And I don't know whether, Howard, did you expect that? Certainly, I like to make surprises. You were surprised? You know how I said I thought I'd make a surprise.
The crowd was taken by surprise. The aircraft could fly, but that flight lasted only 1 mile. It would be the only time the H-4 ever flew. Why it never flew again remains a mystery, as does whether Hughes had planned the flight in the first place. Despite its single flight, Hughes felt vindicated, proving his critics wrong. Today, the Hughes flying boat rests in dry dock, still an intriguing curiosity, much like its enigmatic creator. Unlike the Saunders-Roe Princess or the H-4, the Martin Mars was a true success. In its 15 years with the U.S. Navy, including its wartime service, the Mars logged more than 87,000 accident-free flight hours. It carried over 200,000 passengers and traveled almost 12 million miles. From troop transport to cargo supply, and even as an air ambulance, the Mars proved its versatility. One of its most unusual missions was Operation Hayride. The Marshall Mars was called in to drop several tons of hay and containers of worms to replenish the food stores for a ship transporting 6 elephants and a variety of tropical birds. Thanks to the Marshall Mars's enormous cargo capacity, the hungry animals arrived safely at their destination. Unfortunately, the Marshall Mars was lost to fire during flight tests in 1950. However, the remaining 4 giants, the Philippine Mars, the Marianas Mars, Caroline Mars, and a second Hawaii Mars, continued to serve the Navy proudly until 1956, when they were decommissioned. Though the Navy no longer had use for them, the Mars aircraft would find new purpose elsewhere. Following a series of devastating fire seasons in the late 1950s, a group of Canadian timber companies formed an organization that would forever change the odds in fighting forest fires: Forest Industries Flying Tankers, or FIFT. FIFT owes over 40 years of successful firefighting to the Mars aircraft, which, despite their age, proved to be the most effective water bombers ever used. On Sprout Lake in Vancouver Island, British Columbia, the last 2 remaining Mars aircraft continue to operate today as water bombers. After FIFT purchased the remaining 4 Mars aircraft in 1959, each was modified to carry a 6,000-gallon plywood water tank equipped with release doors either in the bottom or sides of the hull. As Ian Thomas explains in their second life as water bombers, the Mars aircraft once again led a career of exceptional performance.
This is LYK, the side dropper Philippine Mars. This is our water tank that we carry the water in. It comes in the back and through the probes, comes through the door system, and loads up in through a set of flapper doors. The tank is broken into 4 sections that we can either drop the front section or the rear section, but usually when we're dropping on a fire, we drop all 4 sections at once, just so that we have an avenue out that all our weight is gone.
Their immense size and capacity made them unmatched in their firefighting role, cementing their legacy as the giants of the skies in both war and peace. Up to 40 fires have been extinguished annually by the Mars aircraft. Within 10 minutes of receiving a call, the Mars is airborne, capable of making a 6,000-gallon drop every 15 minutes, totaling 30 tons of water per drop. This speed and efficiency make the Mars invaluable in firefighting. However, fire missions are infrequent, and the greatest challenge is maintaining these aging workhorses. Every morning, flight crews perform thorough checks to ensure the aircraft are ready when needed. Since no new parts are made for the 50-year-old planes, maintenance becomes increasingly difficult. When the Mars was first purchased, they came with 35 engines and 90 tons of spare parts, which initially sufficed. After 30-plus years of operation, even this stockpile began to run low. In the early 1960s, 2 of the original 4 Mars were lost: Caroline Mars to a hurricane, and Marianas Mars during a fire mission, leaving 2. The remaining Mars became even more precious to the crew that maintained them. They were not just aircraft. They were a lifeline.
Well, I was originally born and raised here in Port Alberni, and these aircraft were on the lake as I grew up. And seeing them, I kind of always wanted to sort of get around aircraft and had it as a hobby.
Ian Thomas, a flight engineer, describes the Martin Mars as a unique aircraft and his job as one of a kind.
It changes every day, that every day you're not doing the same thing, that we're not fighting a fire, we're doing maintenance of one sort or the other. It's routine, and yet the place and the airplanes are part of you. It's a great crew. Everybody gets along. Everybody looks after one another. You care about one another. You're not just a number in a mill or in a factory. That everybody's got a personality and everybody knows everybody, and it's nice.
The close camaraderie within the crew stems from the highly efficient teamwork. Thomas knows that a successful and safe mission relies on flawless interaction with the pilot.
Pilot has the eyes. I am sitting 30 feet back. I can't really see what's going on. I rely on him, but then he relies on me to maintain the aircraft and operate the engines when he needs the power to get out of a jam or to function in his movement of the aircraft. He relies on me to maintain and achieve that power settings that he's desiring.
Becoming a pilot for the Mars is no small feat. Applicants must have at least 7,000 hours of flying experience, specifically in water-based aircraft along the British Columbia coast. Chief Pilot Jack Waddington recalls his first flight with the massive Mars.
The first time that I recall flying the aircraft, I know I was in great awe of it. Somewhat intimidated. It's very slow to respond, both power-wise and on the controls. The first time you take control of the aircraft, you kind of say to yourself, my Lord, what have I got a hold of here? But it comes around after a while. It's very much, I would have to say, the ultimate flying boat. It's the largest operational flying boat there is, and there's nothing can compare with it.
Pilot Reg Young.
I enjoyed playing the aircraft right from the start. I really enjoyed it. I mean, I couldn't seem to get enough of it. On my first flight, I took the controls and did a complete takeoff and landing, and it was super. Like every pilot, you see a new aircraft, you want to fly it. When I saw the Mars, I was hooked. I mean, I had to fly it.
Well, I think there's 2 things that really make this aircraft ideally suited to water bombing. Number 1 being a flying boat, We have water everywhere here. We're never any more than 10 minutes away from water, whether it be fresh water or salt water, it doesn't matter. The other thing that makes this aircraft ideally suited is it's a simple aircraft, what we refer to in the aviation community as the KISS principle, keep it simple, stupid. It applies to a lot of different things, but I think with aircraft firefighting and water bombing, that you definitely do want a simple aircraft, not an aircraft that's overly complicated. The more complicated they are, the more things there are to go wrong with it.
Well, it's kind of a neat airplane to fly. The whole aircraft is flown through intercom. The pilot's in command, passes the commands out to the flight crew. And the main commands are between the pilot and the flight engineer sitting on the flight panel 30 feet behind you.
Clear for.
The pilot applies the power for takeoff, and as soon as you get directional control with a little bit of speed, pass the power back to the flight engineer and he adjusts the power for you. From then on, you call commands for whatever power settings you want, whether you're in a climb or a cruise attitude. He manages your fuel system, does all your electrical system, all your fire warning system. Important guy back there. His job is to inform the pilot if anything goes wrong, and the pilot will make the decision on how to handle it.
On fire missions, teamwork extends beyond the flight crew to the aircraft itself. A crucial element of these operations is the bird dog, a Grumman Goose amphibian, which helps guide the Mars during firefighting operations. The bird dog serves as a spotter for the ground-based fire boss, who oversees the entire air and land firefighting operation. The bird dog not only provides reconnaissance, but also guides the Mars bomber in for the water drop. Operating the Mars on fire missions requires a crew of 4: pilot, co-pilot, flight engineer, and flight mechanic. While the crew may appear relaxed during a practice drop, the true fire call triggers a surge of adrenaline as they prepare for real operations.
Well, here on the base, when the bell goes off, when you have a fire call, you're usually sitting back, kind of relaxed, not really thinking of having to go to a fire. It's like any city fire hall, the crew's sitting around waiting for the call-out. But when the call-out goes, it gets the old adrenaline flowing, you jump up and you're gone. You're down the boat and onto that aircraft, and the sooner you get to the fire, the better job you're going to do.
Fifths, 4 pilots are the only men in the world certified to fly these aircraft. They form what has been called the world's most exclusive club of airline pilots, entrusted with the unique responsibility of operating these giants in critical firefighting missions.
Well, it's all very second nature to us now. It's I consider it. I've been trained to do the job, and it's just like anyone that's been trained to do a job. You're trained to do it, and it becomes second nature to you after a while. It's just like getting in a car and driving it.
While it might not be like getting into a car each morning, after extensive training and operational flying, piloting the Mars becomes second nature. This is vital when facing forest fires, which are unpredictable and dangerous. The Mars was not originally designed to navigate through rugged terrain at treetop levels, and its limitations became painfully clear in 1961. The pilot of the Marianas Mars attacked a fire uphill, but during a steep turn away from the mountain, the port wing clipped the trees, causing the aircraft to cartwheel into the mountainside, tragically killing the entire crew. Since then, Fifth Management has emphasized that pilots must be just as familiar with the terrain as they are with operating water-based aircraft. Familiarity with the environment is the first requirement for safety. The second is teamwork, an essential element for ensuring successful and safe fire missions. Once the flight crew takes the Mars into the air, procedure becomes paramount. Every action is carefully planned out in advance. There are no last-minute changes or decisions based on impulse. Too much is at risk, both for the aircraft and especially for the crew. Over the years, perfecting these procedures has saved millions of dollars worth of timber. However, navigating through the remote areas of the island demands great skill.
Well, the forest industry has changed. Now all the lowlands are logged off. The logging has moved into the mountainous country. So naturally the fires are in that area created by operations. And we're going more into the mountainous terrain, valleys, block canyons, and it calls for a lot more skill and types of flying to get in there to get at the target, which is the fire.
This is evident in a past fire site that got out of control before the Mars was called in to assist.
Well, the old technique was they used to wait till the fire got completely out of control. They tried to fight it with small helicopters. Then they would call us in there, and I mean, the thing was burning everywhere. Open flame, 20, 30 feet in the air. We'd come in there, and in an hour, it was out. Now, when we get some type of fire in any of the logging operations, they call us out, we're in there and we put it out. I mean, our whole drop pattern, 2 to 3 acres, covers the fire. And we have it out in an hour. So the idea is initial attack, get on the fire as soon as possible and get it out.
Filling the 6,000-gallon water tank takes around 40 seconds. At 80 miles per hour, the Mars skims the lake's surface, pushing water into 2 large probes resembling enormous ice cream scoops that extend behind the step. While it might sound complicated, it's a process the crew has perfected over time.
Scooping the load is really no big, heavy problem. You fly it the same as any other aircraft. You always pick up into wind. But once you get the aircraft airborne, then you're just a heavy, slow-flying aircraft that's slow to maneuver. You need lots of room to get your speed up, to climb out. It's 10 times slower than when you're empty. I mean, I've had it so that I'm sitting there with my left wing down, cranked full aileron over to bring it up. I mean, cranked right over. Nothing happens for seconds and seconds. You can eat up a mile of airspace before the thing finally starts to move, and then when it does move, it just comes up slow. And it's heavy. There's no boost on the aileron. You have to have a plan to fly the airplane on operations. You just don't come around the corner and everything happens unexpected. Your bird dog's there before you, tells you what to expect, so you're all set up. It's up for the pilot to maneuver the aircraft on final to the proper drop height and let the load grow just by eyeballing what's happening outside relative to your speed.
30 tons of water, mixed with foam concentrate for deep saturation, crashes down like a thunder shower. But rarely is one pass enough. A tough fire may demand up to 25 drops per sortie, with 2 sorties per day. In this high-pressure environment, there's no room for error.
You're fighting the air currents, the weight of the aircraft, smoke, and mountainous areas. That's the hazards of this type of flying.
Yet the fires always get put out. In 40 years of service, the Mars has never allowed a fire to escape control. Without these water bombers, it could take ground crews a week to contain a remote fire if they could even reach it. Though dangerous, the job comes with a reward, an awe-inspiring workplace surrounded by beautiful landscapes, which is part of the appeal of seaplanes over land-based aircraft.
Well, flying this aircraft in any seaplane application, every runway is different. You're always going to different places, different water conditions. I think that's probably what got me into the seaplane flying business in the first place. Somewhat now, I guess 30 years now.
And for flying boats, the Mars stands as the granddaddy of them all. It's a unique combination that blends the thrill of firefighting with the charm of flying over breathtaking terrain.
These two aircraft, probably the last of the flying boats you'll ever see. I don't think you'll ever see them again. It's going to be a sad day, I think, when they eventually do go. We're trying to keep them going just as long as we possibly can. We're not abusing them. We have great respect for them. It's definitely an era gone by, but we still got two of them flying here, and they're doing one hell of a good job.
Perhaps only Glenn L. Martin could have foreseen that his flying boat would still be operational 50 years later. While not originally intended for firefighting, flying boats have long been recognized for their versatility. The Mars has survived an era when the sheer size of flying boats was considered a liability, yet it has ultimately turned this characteristic into its greatest strength. The Hawaii and Philippine Mars are not just exceptional machines. They hold a special place for the crew who operate them.
They're just a part of you. It becomes your sort of baby that you look after it and you maintain it and keep it in flying condition. It hurts to see somebody else break it.
These aircraft are more than just tools for the job.
These planes are works of art that are a dying breed.